Okay, so today we're going to be talking about UI testing. Before we get into that, I wanted to answer a couple of questions that came up from the stand-up last night. The first one is, how do we know what to test? This is a really good question, and I think it ties into why iOS developers kind of are a little bit scared about unit testing, because they're not really sure how to answer this question. When we do unit tests, we are testing the logic of our app. We're not necessarily testing what the app looks like. That's what we're going to be talking about today with UI tests. With unit tests, we're testing the logic. So kind of like how we separate our app into the ideas of model, view, controller, as a way to keep unrelated part code separate from each other. We separate our tests as well. So we have logic tests, which are the unit tests, and these are verifying that our algorithms are correct and that our model is staying consistent and so on. And then our unit tests, our UI tests, are for testing that when we are interacting with the UI, that things are changing in the ways that we expect them to change. So as you're writing unit tests, it can be helpful to think about this sort of separation in your code of, am I testing the logic of my app or am I testing the UI of my app? What logic do I have that I need to test, and so on. Once you've made that distinction and you've started writing unit tests, there is another feature of Xcode, which we did not cover yesterday, but which I will show you now, to help guide you on finding things that you have not yet tested. And this is a feature called code coverage. So I'm going to share my desktop. And I'm going to bring up a project of mine. This is a framework I write and that I've posted on GitHub called DD Math Parser. And then at a high level, this is basically a way to turn a string of an equation or some math expression that somebody has typed and parse it all out and figure out what the math is, and then in the end evaluate it and come up with an actual number. So there's a lot of stuff going on here. It's a fairly complicated problem. But one of the things that I've got in here are various kinds of tests. So I can test, am I able to parse an empty string or a string that's just white space or 1 space 2? And there are different levels of parsing. So this is just verifying that I'm able to correctly find tokens or individual parts of a string, and that they're coming out to be the kind that I expect them. So here's a decimal number followed by an identifier. Here's a decimal number. Here's a fraction, and so on. And then I've got other tests, and these are all just testing the various phases of parsing until I get all the way up to can I actually turn this string into a full-on expression, which is kind of like the final parsed form? And is that expression the kind of expression that I'm expecting? So in this case, this is the factorial function that takes an argument of the number 4. And when I run these unit tests, so I do product test, it's going to build, and I've actually got a couple of failing tests in here, which is good. It shows me that I've made changes, but I've somehow broken functionality in my app. So I've got a decent number of tests. Let me expand these all out. And these are all just, like I said, testing different cases of parsing. When I go over here to this last tab in the navigator, this is the reports navigator. Normally, I would see, here's the results of my build. I can see, here are the results of my unit tests and how long each one took. One thing in here is that every time I run my tests, there is a report called coverage. And if I expand this, the coverage report shows me that for all of the files in this framework, what percentage of the code did the unit tests actually cause to be executed? So if I go over here to something like my fraction number extractor, when I ran these unit tests, 100% of the code lines in here were hit. And I can see over here on the right gutter, how many times this method was called. This was called 2,070 times. This extract one was called 33 times, and so on. And so by looking at these numbers, I can get an indication of functionality in my code that I am not testing yet. Okay, so for example, there's a file here called dynamic resolution, and there's a lot of declarations in here, but you don't really test protocols because there's nothing executing in here. But I do have some lines down here on a thing called a substitution, and none of my unit tests are testing this code. So this gives me an indication of I have code in my app that I don't know if it's working correctly because I'm never testing it. So I could use this as a way to go and construct a new unit test to see if I can carefully construct some input that would cause this code to be run. With this in mind, you might think that maybe my goal should be to get 100% code coverage on everything. And that is certainly a worthwhile goal. Sometimes, though, it is impossible. Let me see if I can figure out. I had one. Here we go. Hex number extractor. So this is part of the parsing that just looks for numbers that are written in hexadecimal in the string. And I see that there's a part in here that's never tested. It says 0 for the number of times that it was executed during my test. And you might think, well, maybe I could come up with a test to hit those lines. The problem is that the way that my code works is that this method, matches preconditions, is always called before the extract method. And if you noticed, matches preconditions here is doing the exact same logic as right here. Which means that, in theory, lines 21 and 22 would never be hit, right? Because the extract method would never be called, because the matches preconditions method would say you're not allowed to execute the extract method unless this returns true. I could write some tests to create a hex number extractor and then just manually call extract on it, which might be a valid test to do, I suppose. But that's just an indication of that, like, not everything is always testable. Another example, I have things in here like just kind of like the equivalent of a force unwrap, where I unwrap an optional variable, this operator token set, and if it's missing, I will just crash the app. And the reason I'm doing this is because right here above it, I'm saying if it's nil, create one, but I only can get the value by unwrapping it. And so in theory, like, this is an impossible piece of code to hit. And so I can't write a unit test that would cause that fatal error to execute. Similarly, things like this, an implementation flaw means that something is terribly wrong. So the idea of getting 100% code coverage, it's a good goal, but it's not always possible. However, using this coverage report is a great way to find areas that are not being tested, and this can be really helpful in guiding you towards finding parts of your code to add more tests for. If you want to enable this sort of reporting on your code, you would go up here to the scheme editor. You would choose Edit Scheme. And then here under the test action, you would make sure that this checkbox for code coverage is checked. Okay. Any questions about code coverage? It's a pretty handy tool, I think.
Is that a setting we have to set each project, or is that like a setting we just put permanently?
That's a great question. Let me pull up tic-tac-toe here. Edit scheme, go to test, and it looks like it is turned off by default. So I'm just going to turn it on for tic-tac-toe.
Cool, thanks.
All right. So today, then we're going to be talking. Oh, sorry. Did somebody else have a question?
Yeah, I don't see that option. It's under test debug and it's under arguments, or is it under?
Oh, sorry. I go to the edit scheme, go to the test.
Option.
Oh, sorry. It's under options.
Okay. Thank you.
My mistake. Okay. So we're going to be doing UI tests today. The difference between a UI test and a unit test, like I explained a minute ago, is that unit tests tend to be verifying that the logic is correct. And when I say logic, I'm referring to the kind of that our model is getting updated correctly, that our detection, in this case of tic-tac-toe, of a winning board is correct, and so on. Our unit tests are not testing that, when we tap on a button, for example, that an X or an O shows up. And those are the tests that we're going to add today. So within the tic-tac-toe project, I'm going to select the Xcode project from the file navigator, go to the list of targets, and then click the plus button at the bottom to add a new target. I will scroll down to the test section, and instead of adding a unit testing bundle, this time I want to add a UI testing bundle. So I will do that, click next, and then just click through all of the default values and click finish. So once again, I now have a new target showing up here, a new bundle, the Lego brick looking thing. And I have a new folder with a UI tests file in it. And now I want to talk about the other question that came up yesterday, which is, when are setup and teardown actually useful? And they are useful in logic tests, in unit tests, but they are also useful here in UI testing. And in fact, when we create a UI test by default, we get a setup method with some code in it. So let's take a look at what's going on with the setup method. The very first thing is we're just kind of specifying that for this test, if we encounter a failure, we want to stop right away. This is particularly useful with UI tests because if we've broken something in our UI, then chances are pretty high that everything after that will be broken as well. So if something does break, we could potentially get a lot of false positives, a lot of things that look like they failed, when really it was maybe just the first thing that failed, and then everything else kind of cascaded down and failed because the first one failed. So we're going to say that if we encounter a failure during one of our tests, we're just going to stop. The second thing we're going to do is we're going to instruct our application to launch for every test. One of the things we did not talk about yesterday was how these tests are actually run. This is something I think is quite interesting. Within our board tests, we have a number of different test methods. We have 5 different methods right here. What happens is that when XCTest is running our tests, it's not going to create just one instance of board tests. Instead, it's going to scan through the class, see that there are 5 test methods, and then it will create 5 instances of board tests, the class. So it will allocate this 5 times. And what it's essentially going to do is this. It will create the first board tests. It will call test1.setup, and then it will say test1.test horizontal win, test1.teardown. And then it will do let test2 equals board tests, test2.setup, test2.test vertical win, test2.teardown, and so on for each of the 5 tests. So our setup and teardown methods are actually called before and after every single test, and they are actually called on different instances of the board tests class. So when we implement this setup method, we are saying for this one test, we want to stop as soon as we encounter a failure, and we need to launch our application. We could do something else here. For example, we can say that the app is in a specific setup. Maybe it's in like a horizontal versus vertical orientation, and so on. And this means that our test method itself can focus on just the little piece of test that it's going to do. So what I want to do here is in this test example, I'm just going to grab the app, which is the UI application. And in fact, I'm going to be using this app a lot, so I'm going to make it a var app, which is XCUI application. And then here in my setup method, I will say the app is XCUI application, and now I can say app.launch. And now here in my test example, I'm actually going to print the app because I want us to see what's going on. And then I will click the run button for these tests. And maybe you put a breakpoint here, and we see tic-tac-toe is launching. And here we go. It launches, board shows up, and now we are here in our test. If I PO the app right now, we're going to see a ton of stuff. The app, this XCUI application, is something called a UI element, an XCUI element. And an XCUI element is basically a way of referring to something on the screen. Sure. Something on the screen that is visible. Ivan asks, is there a reason I didn't instantiate the app when I declared it? You're talking about right here. Mainly I did it this way to just kind of show another reason why the setup method is nice. I can declare my variables, and sometimes when I'm setting up a property, I maybe don't have everything I need right at the init time in order to create it. So maybe I do it during the setup. but you are correct, I could have just done this. But to illustrate using the setup method, I decided to do it down here. Our XC UI element, this is basically something that exists on screen. We can see that we've got a way to wait for the element to exist. So we can even get a way to refer to something on the screen, which we'll see later, that does not exist yet, and then we can wait for it to exist. So maybe we know a button will appear after an animation, for example. We can verify that it exists. We can ask for things that are underneath it, things inside of it, like subviews. We can ask it to type things. Here we go, type this text. So this would be useful if my element refers to a text field. I can instruct it to type a string, or I can even go down, let's see, these ones are on Mac OS, so maybe not. Here's hover. This is moving a cursor, again on Mac only. I can click on things, or I can tap on them. I can double tap. I can press and then drag to something else, perform swipes, and so on. If I want to inspect this element, I would look and see that it conforms to a property called XCUI elements attributes over here. So I'll click on that. And now I can see that it can have some sort of value. It might have a title, it might have a label, and so on. And we will be using these as we create tests for our application. One of the other things I want to show is the fact that an element also has ways to refer to elements inside of it by what they are. For example, I can find all of the activity indicators, or all of the image views, or let's see, labels, I believe is one of these. Here's one for buttons. We'll be using that as well. Oh, here we go, text fields, and so on. So the XCUI application that I've created is an XCUI element. So everything that we just saw about being able to find buttons and find labels is possible with our application. UI application just adds a couple of other things, such as determining what the state is. The state refers to whether it's running in the background, and so on. So I can even write tests to make sure that my app is behaving correctly when it goes to the background. Then I can also quit the app and launch the app, and so on. So if I look at this XCUI application here, I can see it's an application. It's got our UI window. And within our UI window, I see some static text that says just label. Here's a button that says restart. Here are 3 buttons that all have an empty string as the title, and so on. So this is probably our grid. And there we go. So I'm just going to continue, and that will pass. So when we think about these tests that we want to perform, let me pull up our main storyboard. Our app is pretty straightforward, just a single screen, right? There are kind of like 3 different categories of things that we want to do. First, we want to verify and test that the elements we're expecting exist. So that we want to verify that when we run the app, we've got these 9 buttons, we've got our status label, we've got our restart button. So we need to verify that things exist. Next, we need to verify that we are able to interact with the things that we expect to interact with. And then third, we verify that the way in which we have interacted with them is correct according to what we are expecting with our app. So I'm going to come in here and I'm going to create a basic test method, initial state, and I've got my app instance already. And so now I won't need a way to find that label. So the question is, how can I find that label? The one that says, well, it says label right now, but we know it's our status label, right? We want to put the status in here. Any ideas on how we might know which label we're looking for?
By its name?
Yeah, by its name. One of the things that brings up a good point here is I have not done @testable import tic-tac-toe, and I actually don't want to. The reason I don't want to is that importing the tic-tac-toe module gives me access to the code, gives me access to the logic of the app. But that is not what I am interested in testing. I'm interested in testing the UI of the app. And you can say, like, yes, game view controller and board view controller, those are, UI of the app and so on. But really, I'm more concerned about what is on screen. And in order to test what's on screen, I don't need access to the code. I'm just going to ask the screen what it knows about. So I don't need the @testable import tic-tac-toe. What I do want is a way to find that label. So I'm going to go back to that element and look at that query provider stuff, and I'm going to look at down here for, is there texts? And I see there is a thing called static texts. And when we had printed out before, there was a label and it had a thing called static text. So I'm actually going to say let status label equals app.static texts. And here I can look it up somehow. I can pass in a string as a subscript. And this string is going to be used to by the app to dig around in all the things it knows about until it finds a static text that matches. So right now I can see that there's a static text and it has a label called label. So I'm just going to say look around until you find the static text that has this text on it. Okay. And now I'm going to run this test again. And the app launches. And I've stopped here. And in my variables view, I can see that I have a status label. So let's PO status label. And it found, here's a static text. It's got, looks like it's got something that looks like a frame right here. It's got a label. There's nothing inside of it. Here's how we found it. It's path and so on. So it looks pretty good. And now I can say, PO status label dot exists. Does this actually exist on screen? And it says true. So good. I can ask for what is its label, the raw string inside of it. And it says it is the string label. Okay. This other output here, this T equals stuff, this is kind of a debug output from XE tests to indicate what is it looking for in order to find what I've asked it to. So here I can say my initial state, I can say xct assert equal that the status label.label is equal to the string label. I can also say xct assert true that the status label exists. And this is how I'm testing the initial state of my app. So I can get the restart button as well. No, I don't want a static text. Now I want one of the buttons. And I'm looking for the button called restart. And I'm going to say xct assert true that the restart button exists. And I'm going to assert that the restart button.title is equal to restart. And I'm going to run this test again. And it failed. Okay, why did it fail? It said it was an empty string, so maybe I don't want title. I will run this test again. And we can see if I want a title, a label, or something else. So let's see what the restart button has. And I'm just going to do that by saying PO restart button. And it looks like, it has a label and not a title. So let's check for the right attribute. Okay, and we'll run the test again. Okay, we passed. Now I want to verify that all of my 9 buttons are blank. Okay. And I could say, how would I do this? I've got those 9 buttons. They've all got the same label. So how can I refer to which of the 9 buttons I mean?
Tags?
Yeah, I could. I need to give them some sort of identifier, and maybe a tag would be a way to do that. But this is where one of the really cool parts of UI testing comes in. We know from our app that our status label, that its text can change, right? So looking it up based on what it says in the label is not the greatest way to do it. That happens to work for the restart button. But again, you know, what if we decide to change our button to say start over? Then our test would start failing for just kind of a silly reason. So I want to give these elements identifiers, so I can look them up based on their identifier. So in order to do this, I'm going to go to my main storyboard. And I'll start with the label here and bring up the attributes inspector. One of the attributes in here, if you go to the third pane, the identity inspector, at the bottom there's this section called accessibility. The accessibility attributes are a really, really good hint for how we're going to interact with this element in UI tests. This is also the information that describes how the screen reader, the voiceover feature of iPhone, knows how to read your elements. So you notice that when I have this label selected, it says it's a static text. And that corresponds to how we found our element by looking it up on the app. It was one of our static texts. And one of these fields here is a thing called identifier. I'm going to give this label an identifier. I could just call it something like status label, and that might be okay for this sort of small app. This can be any value you want. Just make sure it's probably unique to keep things easy. If you're worried about identifiers overlapping or colliding with each other, if you're worried about multiple elements have the same identifier, you could say it is something like the game view controller dot status label, for example. So I'm going to give that identifier here to the label. I will give another one, game view controller dot restart button. And now for the board, let's just do this board view controller dot tile 0. And I will copy this, paste this in for all the others, but change it to tile 1, tile 2, tile 3, tile 4, tile 5, 6, 7, and 8. And then I will save the storyboard. Command S, make sure that that actually saves. Does it? Yeah, please save. And again, notice that these buttons, in their accessibility traits, it says it's a button. So we are going to look it up based on it being a button and not a static text. So I will give you about 3 minutes to catch up with this and put in all of the accessibility identifiers for the status label, the restart button, and the 9 tile buttons. Please raise your hand in Zoom when you are finished. That way, if everybody finishes early, we can move on sooner. Okay, Sergey and Lotana, are you done as well? Thumbs up. Cool. Thank you. All right. So now that we've given these identifiers to our buttons and labels, we can go back here and change it from being just label, and I can type in GameViewController.statusLabel because that was the identifier I gave it. And same thing here, instead of status label, I can call it restart button. And let's run this again.
You think static text, do we need to change to identifier?
Nope, because I'm still saying I want to find something that is a static text. Okay. But it's a static text with this particular identifier. Does that make sense?
Yeah, but they don't confuse to look like that text or the label text.
This thing. The part here in the subscripts is just kind of a matcher. I'm saying find a static text that somehow matches this. And what XCTest is going to do is it's going to look at a bunch of different properties on the labels to try and find something that matches. So it will look at the label, it will look at the identifier, it might even look at some other things. But it's going to look in multiple places on each label to find the thing that matches.
Gotcha.
Good question. All right, so I can test my initial state now. And with my, for the buttons, I can say for button number in 0 up to, but not including 9, let identifier equals, this was a board view controller dot tile, and then I will pass in the button number. And I'm just going to look for the buttons with that identifier. And now I can say XCT assert true, that the button dot exists. And I can XCT assert equal, that the button dot label is equal to a string with a single space in it. Okay. And if I run, this is all going to pass. Boom, there we go. Great, so this is my test that everything exists. Let's start testing what happens when I interact with it. So this is my element existence. So now let's test the element interaction. What sorts of interactions can we do?
Up only.
Yeah, so what can we tap on?
Buttons.
Yep, we can tap on the 9 tiles. Is there anything else?
Yeah, a reset button.
Yep, and we can tap on the restart button, right. In order to do these things, I'm going to need access to these buttons and the static text and stuff. And so I think it might be a little bit easier to just turn these into like a property. So I'm going to copy out this status labels thing right here. And I'm going to come up here and I'm just going to say var status label. This is an XCUI element. And it will be just that one thing. And I will do the same thing. And now I don't need that line anymore. Can do the same thing for the restart button. Like this. And now for the tile buttons, I have to pass in a button number, so for that I'm going to use a function. And I will copy these 2 lines, paste those in, and instead of button number, it's just index, and it is return that. And now I can change this to be let button equals button at button number. And it might complain because these are both called buttons, so I'm just going to say, sure, self dot. Okay. I'm going to need some other little helpers as well. So for example, well, let's test.
Sorry, could you pause for a second, show your function, the button at index?
There you go.
Thank you.
Yep. For some other helpers, I'm going to declare a couple of enums. And this is just so I don't have strings everywhere in my code, like this sort of string. What I want to do is I want to use that mark enum. So we've got an X case, an O case, and we also now actually have an empty case. And I'm going to give them a string value and just switch and say return capital X, return capital O, and empty will return the string with a space on it. The other thing I'm going to do is add an enum for the status texts. But I'm going to leave this blank for now, and we will fill this out later. But this mark enum we're going to start using right now. So I'm going to create a func test tile taps. So I'm going to say the first button is button at 0. I'll call that B0 just so we don't get confused. And now I can say B0.tap. And what do I expect to have happen when I tap it?
If it's first tap, the label, that button title is supposed to change.
And what should it change to?
To the mark X.
Yep. So I'm going to say that the button label should be the X string value. And I can now get button at index 1. And I can try tapping that and say that I'm expecting that one's label to be mark.o.string value.
Do we need to do all 9 buttons like that?
Might as well. So I'm just going to copy and paste this 7 more times. 4, 5, 6, 7, 8, 9.
That's requirement to test like all the buttons, or couple if it works.
It's not a requirement.
Should you just put it in a for loop?
You could do it in a for loop. I'm specifically gonna tap them in such a way that we end up with a tie game, just so I can verify that all of these end up working. So I want XOX, XOX, and oh wait.
We need to check all possible cases.
No.
Not for the like marking past, for the testing, like for the previous unit test. I'm not sure like when it's enough to test, like when it's like need to more have tested.
What I'm specifically looking for here is this. I'm just looking for a way to test that when every button is tappable, and that tapping a button will cause its label to change. And the way I'm going to do that is by making a tie game, because that's the scenario in which I'm able to tap every button. So X0X, and then I want to tap button 4, and then let's see, XO. Let's see. I'm missing something here. I've got these in the wrong order. Okay, 0, 1, 2, 4, 3.
If you will tap from the left to the right, the second line X is supposed to be 0.
But I have to tap them in alternating order, right?
Yeah.
So I can't tap this button to get an X and then that button to also get an X.
Right.
So, and
You can bring it 9 to the third line.
there we go. Let's see, X. I think I need to do something like this. And this is a really good example of how order matters. Okay, I think I've got it. Now, this is a lot of repeated code, so maybe this is something that's worth pulling out into another helper function. So I'm going to pause here and write a helper function. I'm going to call this tap button and pass in a number, expecting mark. I'm also going to pass in 2 other parameters called the file, and I'm going to give it a default value of #file, and the line, which is a uint, with a default value of #line. The file and line are these special placeholder values. We saw them a little bit when we were talking about logging and debugging as ways to enhance your log messages. And they are used by XCTest to annotate and to show where tests have failed. So when I tap a button, I'm just going to get it as self.button at whatever number. I'm going to say tap this button. And now I'm going to assert that the button.label is equal to the expecting mark.string value. And here I'm also going to pass in the file and the line, like this. Oh, this needs to be a static string, not a string. Okay, so this is just a little helper method. I will copy and paste this into Slack for you, so you can just use that. And now all of this, I can say, hey, tap button at 0 expecting.x. tap button at 1, expecting .o, .o, tap button at 2, expecting .x, tap button at 4, expecting .o, tap button at 3 is an x, tap button at 6 is o, tap button at, what do I need next? 5 is an x, tap button at 8 is an o, and tap button at 7, expecting x. And now I can delete all of that. And this is much nicer to look at. And again, I will copy and paste this for you. There you go. And in fact, I'm just going to change this slightly for me, just because I care about naming things. All right, now if I run this again, oh, this should now be just mark. If I run this, we should be able to see tests happening. We should see buttons getting tapped. Sweet. And it all passed. So that means that we were able to tap all those buttons and all of their labels correctly updated.
Cool.
Now, there's some other things that we might expect. For example,
Label change.
yeah, the label's going to change. And in fact, we want to test two things, right? We might want to say test the label has the right value before the test, in which case it should be player, mark turn. And then afterwards, it maybe should be player other marks turn. Do we want to test that last one?
On this particular case, on that function we can't test because we don't know how we'll end the game.
Right.
But the tile taps, we can check the label text if it's equal game is cut.
Yeah. So this is where I want to come up here to these status texts. There are a couple of different things that might show up in the status text, right? So we might have player X turn, case player O turn, case player X win, case player O win, case tie game, right? And just to keep this easy, I'm going to say they look like this. Player O's turn. Player X wins. Player O wins. And this is Cat's game, I think, right? Okay. So I just need to change these. This is a lowercase t. This is lowercase 1. And Cat's game lowercase with an exclamation point. All right. Now I can say that when the game starts, I'm kind of expecting this label to say that it's player X's turn. Right? Or not win, turn. So if I run this test now, and this is just kind of what I'm expecting, that when I start up, the app should be in a ready to go play a game. And I'm going to fail because that's not what it says, right? It says label is not equal to player X's turn. So this would be an indication of, here's something I can do better. I want to clean this up a little bit. I want to be able to say, maybe pass in a mark. So maybe I want to change this to be case turn and then pass in a mark. Case win, pass in a mark, or case tie, right? In which case now I need to, and I will type this out and give this to you. So case.turn, let mark, and this will be return player mark.string values turn. Case.win, let mark, return player mark.string value 1. Case tie game or tie, return cats game. And now we don't need those. Okay. And now I want to say that this is dot turn for dot x. And I want to do this. Oh, dot string value. I want to do this because here I want to get the status is the status text. And this should be, it'd be the turn for this mark. And now I can say xct assert equal that the status label dot label is the status dot string value. And like I said, I will copy this status text enum for you. There you go. So I've established this expectation that when the app starts up, I want it to say that it's X's turn to start. So that seems like a thing I could do here when the app starts up. Let's see. Restart game, update views, update views. So I think I just need to have it in like my view did load or something. And here I'm going to say super.viewDidLoad and update views. Because update views is where that label gets set. So add that one method with the 2 lines to game view controller. And now when I rerun my tests,
what else were we adding into the view did load?
we're going to have it called the update views method. Okay, and this all passed.
Can you say again why we're adding in the view did load view update view?
Because that's before it was just saying the word label. And
okay.
so when it loads, we want to tell it to actually change what's in this label. And for the game view controller, that is this method, update views, where it changes the status label. So when it makes the UI, we're going to tell it to put the right text in there.
Yeah, but before view did load, I guess we may run. We have that label changed text too. Before turn, I guess. Let me run. Oh yeah, we don't. We need to click on one and then it's changing. Okay.
All right.
Starting to notice that the test code is longer than the actual app code.
Yeah, that can definitely be the case. And so now here we can assert also that our status label is equal to our status text dot tie. You're absolutely correct that our test code is ending up being longer. There are ways to make this shorter. I'm not doing that right now just because I don't want to overwhelm you with too much information. And I just kind of like want to show you the process for how we're writing tests and the sorts of things we're testing.
We're not using the recording button?
That's fine. Okay, so let's try this out. So as we've been finding, writing this all out by hand is kind of lame. So let's do something different. Let's write a method called func test x wins, and let's figure out how we can use a button down here called record. So I'm going to select this line called test x wins. And then down here at the bottom next to the breakpoint button is this red circle. And it says, if you hover over it, you get a little help message, a tooltip that says record UI test. And I'm going to click this. And now it's going to launch my app.
Dave, but you need to click inside the function, I guess, first.
Oh, okay. I will do that here in a second. And boom. And then, so I've been clicking around, and now I can hit the stop record and actually move this code to be the right place. And what do we see? We see that it's been listing out these things for us. Everything that we just did, it put here for us. Now, I don't need the app local variable because I've already got one of those. Here are the buttons, but it says that I've been doing all this tapping, and now I can just type, hey, status label. This should be that X wins, right? A win by X. Dot string value. Or I can do func test O wins and do the same thing here and click record. And now when, oh, okay, let's do X, O, X, O, X, O, and then click stop. And now this is interesting. We see that it's not always right about getting what we need. We don't need this reset button here at the top. So let's see. What did we tap? We tapped 1 and then 0, and it looks like it didn't know how to refer to this last one, so it kind of came up with something weird. But we know that this is going to be buttons board view controller dot tile 5. Nope. 1 0 1 2. Oh no, this was 4. I think. Tap tap.
I think they're all there. I think that was just something extra.
That was just something extra.
Except for when you're out of bounds of the button, maybe.
3 4 5 6 1 2 3. Oh yeah. All right. And now we can test that O wins. Okay. So we could do some more cleanup on this, but this is a really great way to get some preliminary tests written for us, is just to create a method and then use the record button to help us out.
Do we need to check the label?
So that's a great question. We could check the label. We could also start going through and replacing all of these with our tap button call. And we could, let's see, how could we do this? Let me reinforce a feature in Xcode. Let's edit this text Xcode win, or test X wins. I'm going to put my cursor right here after tile and before 0, okay? And then hold down Control and Shift, and then press the down arrow to move the cursor down. And add a cursor before all of these lines, before all of those numbers. Control Shift is how we do multiple cursors in Xcode. So I now have, what is this, 7 cursors all blinking at me right before the numbers. And now I can just start deleting them all the way back to the beginning and start typing tap button and then the number. Now I can press the right arrow to move all of the cursors right, and then say expecting colon dot X, and I'll fix that here in a second, and then save. Now I got the weird indentation because Xcode got funny about that, but if I select all and Control I, then it re-indents. And now I can just go change the ones I care about. So that's a really quick way to change lots of code all at once.
So the record button's still grayed out on mine even after I wrote a function and I'm kind of highlighting in it. Is there a way to get that? Oh, now it works. Never mind.
Yeah, I've found it can be a little temperamental about when it updates. So I'm going to make the same change down here in the test owns as well, to do tap button this, and then I'll just put that in expecting.x, and now I can say that that should be an O, that should be an O, and that should be an O. And if you noticed, when we were recording, it was putting in the things with the accessibility identifier rather than looking up buttons by label or by some long, complicated thing in there. And that is because XCTest really wants you to use those identifiers we put in the storyboard.
That means we can use the record screen without any creating labels, like pre-creating?
You can use the record feature.
They will create for us, right?
If you use the record feature and you do not have identifiers, you will get very, very long and complex ways to refer to a button. And it's kind of similar to doing like view.subviews 2.subviews 1.subviews 0.tap, you know, something crazy like that.
I see.
And that's extremely fragile, right? Because if you decide to change your view hierarchy at all, that will suddenly break. Whereas the accessibility identifier works regardless of how deep things are going.
Okay.
All right. So I've got all of this working now. I'm going to just run all these tests again. And there was the first test. There's that was O wins. Launching it again. Here's the tie game. Here's X wins. Now, one of the things I want to point out is why the app is launching every single time a test runs. What's something that runs every single time a test is run?
We have separate function for that.
Setup. The app is launching every time a test runs because before every single test, we are instructing the app to relaunch. Okay?
Can we say just reset?
Yeah, so let's take a look at XCUI application. It looks like we have launch, activate, and terminate. That's not the greatest, but there is a way to check the state.
We have status button, reset button. Can we call that there?
Yep, we'll get there. We'll get there. So what I can do here is I can say if app.state is not running, or does not equal, let's see, what do I want? Running in the foreground, then I want to do app.activate. And I also want to say if app.state is not running up here, app.launch. And now I can delete that. So if the app hasn't been launched yet, then I want to launch it. But if it has been launched, but it's not in the foreground, then we will just activate it. And in fact, I can just do this as an else if. But if I just run it like this, run the tests again, we'll see they execute faster, but things are going to start failing. So here's the first test. That's O wins, and that's great. But my next test, these are all failing. Who knows why?
Because already X is there and they can't put the same places X again.
Yeah, so, right, because we're in the middle of a game. So what we also need to make sure is that our restart button, we need to make sure that we tap it every single time to start over. And this is the point about this comment. We need to reset everything to the initial state. Okay. And now if we run again, hopefully this should work. And this is looking a lot better. All right. One of the things I want to point out now is if I go down to this last tab, the report navigator, I want to select coverage. And I can look and see within my tic-tac-toe app, how am I doing at testing all of my code? Okay. Game view controller, I'm doing, well, app delegate and board view controller, I'm doing great. Everything's getting tested there. Game board, 90%. What am I missing? Oh, this is, I guess, just the conditions on is valid. And since this code is running in a UI test, this makes sense that I'm not able to hit those lines of code. I could test, trying to tap on a square that's already been tapped on and making sure that the label doesn't change. That'd be a good test. Let's go add that. So func test invalid, or test tapping on occupied square. So I'm going to say tap button 0, and I'm going to expect it to be an X. But if I tap on button 0 again, what do I expect?
An error or a log is invalid.
I'm expecting it to not change, right? It should stay the same. So that shouldn't change anything. But now if I tap button 1, then I should expect an O. Let's try running this. All right, well, we got an error. Oh, because we are asserting the label here. Since we are expecting a specific mark, it's saying it should say label O's turn, but since we passed in X, we need to say it's not label X's turn. So this just means that our logic here is a little bit wrong.
I think you can just change the lines on that function.
What do you mean?
Can you do the function again, please? The bottom one. Yeah, line 162, you just put it on 160.
Like this?
Yep. And
Okay.
they will pop.
Oh, yes, that would work. But that is X trying to tap on their own button.
Yeah, on the same one. You can add it one more, tap button 1, expecting O.
But I want to try, what about O tapping on X's tile? So that would be the case where I run the game. I click first to play the X square, and then what happens if O tries to tap on this again? It should stay as X, right? So what I'm going to do is I'm going to modify this tap button. I'm going to add a parameter called player, and I'm going to have it be nil by default to pass in a mark. And I'm going to say let player mark is equal to player if I've got one. Otherwise, it's whatever the expected mark is here. And that way, I can test the status label independent of what the mark is. And now I can say, well, so this is test tapping on own square. And now I can add another one that this is tapping on other occupied square and put these back how it was. So this will now we'll say for player O, I want to tap on this square, but when I tap on it, I'm still expecting X to be O tries to tap on X's tile. Is this making sense?
Yeah.
So I'll save this, I'll run this one. And there we go, now that passes. So I'm gonna rerun all these tests again, just to regenerate the coverage report. And let's see how our new coverage metrics are doing. And this can help us find more things to test. All right. I guess it. Huh, it didn't gather reports. Let's try that again. And running. There's O wins.
Before start, they trying to press twice restart button.
That's because we've got one test that's just make sure everything is empty. We're not actually testing any interaction. So it runs, it restarts, it does nothing, and then it ends, and then it restarts again.
Okay.
Yeah, it's a little bit weird. Okay, let's see if we got coverage. Yay, here we go. So we're up to 97.4%. So game AI, this is, let's see how this is doing. Now, we don't actually have a UI test for diagonal wins. However, we know that the logic for that is correct because our unit tests have asserted that it's correct. So I think we're doing pretty good there. Let's see. We're doing a bit better in game board. Again, we can't hit the invalid state with UI tests. What about game view controller? Is there anything else we need to stay? This is just like trying. Oh, this is trying to tap on a square after somebody has won. That's an interesting case. Shall we try testing that? So let's just copy this, and I'm going to paste it. Test X wins, and O tries to keep playing. Okay, so 1, 2, 3, 4, 5, 6.
And then all it's win, right?
Yeah, so what we're going to say is O is going to try and tap square 7, but we're expecting that to still stay at X. And we're expecting this to still say that X wins.
But we're not expecting X on button 7. It's supposed to be empty.
Yes, you are correct. Thank you. If I run this, oh.
I'm right? No, I'm wrong.
No, now it's failing on the assertion of the label.
Can we
Right
say
here.
nil?
No, we could add just like more special casing for this, but maybe the thing to do right here is just copy this out and this will be mark.empty and like that. So the problem is that our tap button was trying to do too much. It was also trying to say that it was X's turn, or in this case, O's turn, but we had just asserted that it doesn't say that it said that X had won. So, all right. I'll just rerun this again to show it works now. And then we will take a little break and then come back. All right. And sure enough, there we go. On a scale of 1 to 3 in Zoom chat, how do you feel about what we've been doing this morning? Okay. All right. We'll take a 5-minute break. During the break, I'd like you to think of a question that you have about the things we've been covering so far. We've got a pretty good range of numbers here, so please think of a question, and we'll spend the remainder of the time going over your questions, and we might also look into something called expectations if we've still got time. But before we do that, I want to make sure that you're understanding what we are talking about so far. So let's take a little break and then come back with some questions.
Hey Dave,
Yes.
can you slack the whole of the code of UI test?
Yes.
The whole code, yeah.
All right. Ah, there it is. Welcome back. And let's start listing out what questions you have. And I will just start at the top and work down. Jonah, any questions? Sorry.
Nothing coming to mind. I mean, everything we've done seems to make good sense. So.
Okay. Joshua?
No, and this stuff makes sense to me.
Okay. All right. Sergey?
Why we need override function for teardown if we're not using that?
Okay.
When we're using that function?
So, like, under what circumstances would we use this?
Yeah, what we supposed to like write there when we use that function?
Okay. Good. I will let's I'll get the rest of the questions and then start answering these. Audrey.
I gave a 1 mostly because I was trying to follow along typing with you that whole time, and it was literally impossible. I think I just felt like overwhelmed. But now that I look back at it, I know what things are doing.
I want to interject that I also can't type as fast as Dave. I've kind of gotten to the point where I stop when I get too far behind, and that's why I ask you for the code afterwards, because it does me more good to stop and follow along to understand than it does to try to keep up with your typing.
Hey.
Yeah. But what I would like if you could go over again is like the if else loop in the beginning function, the running foreground, what that's doing, the not running and running in the foreground.
Okay. All right. Lotana says, do we do this all the time while writing code? I understand testing the logic constantly via unit tests, but aren't UI tests mostly obvious? Are you expected to always write UI tests with your code? So isn't this all kind of obvious? Do we really need to do all this work? Okay. Joshua has some opinions on that. I'll put something there, and let's see, scrolling down, Joshua, reload. Ivan, I don't think I've asked you yet.
No, I just basically have the same opinion as Audrey. As far as trying to type and listen to what you're saying at the same time, it's kind of hard to do both.
Okay. All right. Other questions in general? Okay. Joshua, let's start with how UI tests would have helped you last night in answering Lotana's question.
I think, well, I had an issue where I did not have the board hooked up right. And so even though all the logic tests were performing and giving me back the right info and passing, and then I had like print statements showing things along the way, the marks weren't showing up on the board. And I feel like if I'd have had access to a unit test to see that, then I could have maybe identified where it was happening a little quicker.
Mm-hmm. Okay, great. Yeah, so there's a mentality, just this kind of like a quip that we sometimes say of trust but verify. We trust that our code is working because we think we're doing the right things. I mean, we don't usually try to write bugs. So we tend to trust that what we've done is what we think it's doing. Unit tests allow us to sanity check ourselves. They allow us to verify that our assumptions are true, and they do that by approaching our app, our logic, our UI from a different point of view. When we are writing our apps, we're writing them from the point of view of, here's what I want to happen, right? Here's the views I want to show on screen. Here's the change I want to make to the label. Here's the changes that I want to have happen when the button is reset, and so on. UI tests approach this from the point of view of what did happen. So when I tap the button, what did happen? Did the labels actually change? Did the button tap fire the correct method, and so on? And so by approaching our code from both angles, we can trust that we've written the right code, but also verify that we have written the right code. We can start getting into some of the esoteric concepts of, like, what about unit tests to make sure the unit tests are working? And that is kind of like an interesting rabbit hole to think about, but we tend to, tests are a way of challenging our assumptions. And that's always a good thing for us to be doing. So trust but verify. Do we always have to write UI tests? Boy, this is a hard question to answer, because in theory, yes. From the point of view of, do I want to always be sure that I'm writing correct code? Unit tests and UI tests are a great way to do that. In practice, does this actually happen? Usually not. This is, like I talked about the other day, this is, I think, a side effect of how our industry has developed. There is so much pressure on developers to get code written so it can get out the door, so it can be in the hands of customers, that testing is typically not something that managers and product managers want engineers to do, because that takes more time, which detracts from actually shipping an app. It is quite rare to come across a company, an employer, that actually encourages testing and builds testing into the product release cycle. However, it is still a good habit to develop, especially when you're working with unfamiliar code. And in fact, one of the best ways, one of the things that I've heard many employers do, is that when they hire new engineers to come work on a product, they will give them the assignment of write unit tests for our existing code. This is actually a really fantastic way to become familiar with the code base, because you spend the time reading through the code and trying to understand what it's doing and what its effects are, and then formalizing that in the form of tests, right? You kind of turn those assumptions about what this code is doing into formal tests. And that way, you learn what the code is doing, plus there's a win for the team moving forward of, now will they have unit tests, which they probably didn't have very many of them before. So writing unit tests is a really good way to understand an unfamiliar project. So do you have to? No. Should you? Probably yes. Will it happen in practice? Maybe. But the quest to become better at what we do should always be something we prioritize. And testing is something that we definitely, as an entire industry, can be better at. Lotana, you can answer in chat so we don't strain your voice. Does that help at all? Any follow-up questions you might have? Okay, looks like that helps. Awesome. I'll keep watching chat, Lotana, if you think of other questions as well. So what is the app state check about? When we run, well, let's take this out and see if it still works. And I actually don't know the question or the answer to this. I do not know if the app is, oh, it looks like everything has failed. So it looks like when we run a UI test, the app is not launched by default for us, okay? And in fact, one of the really interesting things you can see is that over here, we actually have two apps that have shown up. One is called Tic-Tac-Toe. The other is Tic-Tac-Toe UI tests. This is just kind of a side effect of how tests work and how they run. But as I've been building and executing these tests, if you've been paying very close attention, you've been seeing that both of these icons are getting updated. That means that our tests are actually running in this app, and this app is communicating back and forth with the main Tic-Tac-Toe app. Now, what that means is that we need to actually tell the main app to launch. And so before the test, we'll see if the app is not running, then we want to tell it to launch. Okay? If the app is running, but maybe we've pressed the home button to send the app to the background, or maybe some sort of notification has come in that's obscuring the app or something to that effect. If the app is not in the foreground, if it's not the app visible on screen, we will tell it to activate. Activating an app is kind of like bringing it to the front. It's making it the app that's visible on screen. For example, if you look right now on your Macs, your app, and look up in the menu bar, there's a name of an app next to the Apple button. That is the active app. Might be Xcode, might be Zoom. But you have other apps that are running, right? Maybe you've got a note-taking app. You've probably got your browser running. Those apps are also still running, but they are not active, right? Because they're not the frontmost app. So it is possible on iOS for your app to be running, but just not be the frontmost app. So if this is the case for us, we want to tell our app to activate. Okay.
So what was happening when we were just doing the launch every time?
So what happens when you just call launch? What that will do is if the app is currently running, it will quit it and relaunch it. Because we are telling the operating system, launch this app. But the way things work on iOS is that the app can only be launched once. So in order to launch it again, it has to first quit the old one. And that is totally valid. If that's what we wanted to do for our tests, okay. But since in our case, we're just testing, board state and, labels and buttons and things like that, relaunching the entire app just seems like overkill. And when we were running it before under this method, the tests were very slow. So right now, with the launch and activate check, everything ran in about 2.9 or 2.2 seconds. If we relaunch the app on every test, let's see how long it takes. So you saw the bundle just come in, and now it's going to launch, or no, just, there we go, launch, run a test, and quit, and install, and launch, and test, and quit. And it's going to do this 7 times.
Can we enable the randomize execute order for this?
Yeah, we probably can. And that would be a good thing to test, to verify even further that we're not depending on any specific app state. I'm going to let this UI test finish, and then I'll show again how we can turn that on. Now we're finally running the last one. And okay, so that entire thing took about 60 seconds instead of about 2 seconds before. So this is clearly makes it faster. You can imagine if we had a very, very large app with tons of UI tests, that running all of them could actually take a significant amount of time. This is a real problem that we face in what's called continuous integration, which is the idea of, you know, always have a version of the app built and ready to go. One aspect of continuous integration of our build server or whatever tends to be running tests to make sure that the code we've just checked in hasn't broken anything. But tests can take a while to run, and so there are different strategies that we follow with continuous integration, which might be something like, you know, when we check in new code, we'll just do something quick like run a quick build to make sure that everything still compiles, but then like maybe once an hour, we'll run the unit tests, and then maybe once a day, we'll run the UI tests, just to make sure that things are still working. And that's just because they take time to execute. So randomizing order, that would be going up here to edit the scheme again. And then going in here to the test option, the test action, and going here to the info pane. And then for our UI test, we can click on the options button and select randomize execute, randomize execution order. There is this button to execute in parallel on the simulator. I'm going to check that and see what happens. Click close and run this. And yeah, simulator disappeared. Looks like we've now got multiple, or at least, I think this is that XR is an old one. And looks like it's installing. It's kind of hypnotic to watch this. Just see everything happening. Another cool thing you can do with tests, which I didn't really show, but I'll point out right now, is on the application, if we scroll down, well, let me just bring it up in the documentation. It's easier to show it there. On XC UI application, there is a thing, it says it conforms to a protocol called screenshot providing, which is a way to take screenshots of your app as it's running. And so there are some people who will use UI tests in order to get their app into a specific state, and then use UI UI test to take screenshots of their app in that state as a way to generate screenshots that they need for the App Store. Because you can also do things like specify, for example, what language you want to launch your app in. If you've written your app to be localized or support different translations, you could launch it once in English, run through everything, take the screenshots you need, shut it down, launch it again in Japanese, take the screenshots you need, shut it down, launch it again in Spanish, and so on. Ivan asked a question in chat. In edit scheme build, why is there an option to run for our test? You're talking about these checkboxes right here?
I am.
Okay. Okay, so these are the various actions. So there's the analyze action over here that can goes with this column. The test column goes with the test action. The run column goes with the run action. Profile column goes with profile, and then archive goes with the archive action. So when these checkboxes are checked, it means that this target participates in some fashion in that action. So the tic-tac-toe target, when we run the analyze action, we want it to analyze the target and so on. So if I were to check tic-tac-toe tests as part of run, what that would mean is it would try, I think, to include the tests bundle as part of the entire payload for running.
Does it also run them at build time too, or?
I don't think so. Let me just try running now that I've made this change, and let's see what happens. Because that's an interesting question. I've never tried to do that before. So we see it's installing the app, attempting to launch it. Is anything happening down here? No, not yet. Okay, here it comes. It looks like that doesn't really do anything. So, interesting. I think what that might be for is you can have other targets in your project that are also executable things, such as extensions and so on. And what that might do is launch them all at the same time, so that when your app launches, it also launches your extension, or it launches, if you were writing a Mac app, it might launch a thing called your launch agent, which is a kind of like an app that doesn't have a UI. So yeah, I think that doesn't really do anything for tests because they don't run anything themselves. Good question though. Okay. Let's go back to here. Why does Dave type so fast? Can Dave please type slower? I'm sorry. I will make a point to type slower in the future so you can stay caught up. And thank you for saying something about this. Sergey's question about when do we really need to use teardown? That's a good question. So teardown ends up being useful when we have resources that we want to have exist for every test. So it doesn't really make sense to set them all up individually in every single test function, but we don't want to hold on to them forever. The common examples of these are things called file descriptors or sockets. So these are like system level resources that you use to, write to files, communicate with other processes or other machines or over the network. So you could imagine, let's see, I think it's like this. I've created a file descriptor, which is like I've told the system, hey, given this path, so like users Dave desktop, file.txt, and I want to open it in like rewrite mode. So like open up this file so that I can read to it and write to it. And this is like raw binary stuff out of this file. Then in my tests, I might read and write things to this file every time. What I would want to do, so I'm not messing up the system, is in teardown, I would want to close that file to tell the system I'm done using this now. So setup is like get everything ready that I'm going to need for my tests, and then run the tests. And then teardown is if I set up anything that I need to make sure goes away, I can do that here. You are correct in that we don't typically use teardown because we don't usually need it. It's just available for us in case we do. Does that make sense? Cool. All right. We've covered a lot of stuff today. Hopefully it hasn't been too crazy. I think UI tests tend to be a fairly natural extension of unit testing. So yeah, any last questions before we finish up?
I have just like a general question.
Sure.
Before, just as far as like, this is like so much material, and sometimes I find myself in my head thinking I'm not as good as this. Some stuff comes more natural, and I have an easier time with it. Some stuff I really struggle with. And that along those lines, like how much of being an iOS developer is doing everything? Or are there teams where people are assigned certain parts of the app, or is it very common to design the app from beginning to end?
Great question. To set some expectations right up front, you will never know everything. It is impossible to know everything. Even if you just look at iOS itself, there is so much. It's an entire operating system. It's like you could spend your entire life learning how iOS works as it exists today and never finish. What tends to happen is that people find areas that they have interest in, that they like to do. For some, they really like writing UI code and writing, how an app looks. For other people, they really like writing, things to do with graphics. And so they tend to, deal with like more of the games route. Some people really like doing augmented reality, so they focus on the AR frameworks. My particular areas that I like writing frameworks. I like writing code that doesn't have UI because I don't write pretty stuff. And I don't usually have a designer I can turn to and say, hey, please make this pretty for me. So I like writing code where I don't have to worry about that. Andrew really likes writing Mac apps. I do too. Andrew also really likes writing code that has to do with audio stuff. He's really big into audio code. I've got another friend who likes video. So you just kind of find things that you like. When you get onto teams, there is an expectation that you'll have a general understanding of how things all work. That you could write an iOS app. And I could write an iOS app. I just don't really like doing it very much. So it depends on the team that you're on. If it's a small team of like a couple of developers, then there's kind of the expectation that you'll be a jack of all trades because there isn't enough space to specialize yet. However, if you join a larger team, then really what will most likely happen is that you will be assigned to work on one portion of the app. So for example, prior to working at Lambda School, I worked for Snapchat. I was there for a year. And Snapchat is a giant app. It can look kind of simple sometimes, but it's doing a lot. And the team that I was on was specifically just working on stickers. So when you take a snap in the app, you can add stickers, which are just kind of like the animated GIFs, or put like text on it, or maybe like put like your snap code on there and stuff. Those are generally all stickers. And our team just did stickers. So we would do things like how are stickers stored on the server? How do we transfer them down to the device when you create a sticker in the app? How do we save it? We own the UI for picking a sticker, the sticker picker. It's fun to say. So the sticker picker control, all of that integrating with a sticker picker. We even got into the code where, if you're chatting with someone in the Snapchat app, suggesting stickers that they might want to send in response to somebody else's text or sticker. So like this team there were like 5 of us, and we just did stickers. And there are other teams that just did chat, and another team that just did like the Discover feed, and another team that just did like the effects, like dog ears and whatever. So you absolutely will likely end up specializing at some point. In the beginning, I think it's good to be trying out a little bit of everything, so you get an idea for what's out there, and you get a taste of what it all is, and you'll find things that you like doing more than others. Most people don't like writing unit tests, but there are some engineers who just love it. And they like hire themselves out to companies to like write unit tests and give advice on how to write unit tests because that's what they love. I don't love it, but you don't have to love everything, and that's okay.
Cool. Thanks, Dave. That's encouraging. I appreciate it. Good.
For the project this afternoon, you'll be adding UI tests to, I think it's astronomy. So if you think back to the app with the Mars rover and think about downloading pictures and the sorts of UI interactions that you do with the astronomy app, it should be pretty straightforward. You've got a list of things. You can tap between sols, and then you can look at the details. The stuff, we didn't really get into expectations. If you are wondering how to do expectations so that you can verify, well, let me put it this way. An expectation in a test is something that you expect to happen, but you don't know when it will happen. For example, if you tap on a picture in the astronomy app, you expect that the detail screen will slide over. Okay, but you don't know how long that will take because it's not going to happen immediately, right? It takes about 0.3 seconds for that entire animation to happen. So an expectation is how you can indicate, I expect this UI to appear, and then fail if it doesn't. We saw this a little bit with the elements. There is an element on, or